Hello students, this is Hamza Noor from Aero Education Network, and in this particular video I'm going to solve some questions from past papers of International A-Level at Excel P1 Pure Mathematics 1, and the topic is, it is a combined handout of chapter number 2 Quadratics and chapter number 3 Equations and Inequalities. So in this particular video I'm going to solve some questions from the past paper handout. So first of all, we have this question. Part A says that by eliminating y from the equations, one you have is a linear equation, which is y is equals to x minus 4, and the other equation is non-linear, which is 2x square minus xy is equals to 8. You need to show that x square plus 4x minus 8 is equals to 0. So what you are going to do, you are going to eliminate the variable y over here, and you are going to substitute it into the equation of the curve, so that you would be able to produce a quadratic equation in the form of ax square plus bx plus c. Okay, so as the equation of the curve is 2x square minus xy is equals to 8. So in place of y, I'm going to write x minus 4, so that I can say that the variable y is eliminated over here. So now in the next step, 2x squared minus x squared plus 4x minus 8 is equals to 0. So therefore, we are going to say that x squared plus 4x minus 8 is equals to 0. As per the requirement of part A, we have shown this. We have shown this that we have produced a quadratic equation in the form of ax squared plus bx plus c is equals to 0. So now in part B, it says that hence or otherwise solve the simultaneous equations. It means the same equations which you were given in part A, and you need to give your answers specifically in surd form. Okay, so basically the purpose behind solving the simultaneous equations is to find the points of intersection, the coordinates of the points of intersection between the two graphs. So as we can see that one graph is linear and one is non-linear, and we have already shown in part A that when y is eliminated, so we are able to produce a quadratic equation in the form of ax squared plus bx plus c is equals to 0. So all we need to do is first solve this quadratic equation which we have shown in part A. Okay, so it is in the form of ax squared plus bx plus c is equals to 0. So therefore we can identify that a is equals to 1, b is equals to 4, and c is equals to minus 8. And specifically in the form of surds, a plus minus b root 3. So this means that the factorization won't be possible. Either you need to use the quadratic formula or the completing square method. Okay, so in this case, I'm going to use the quadratic formula. X is equals to minus b plus minus under root of b square minus 4ac completely divided by 2a. So this means that x is equals to minus 4 plus minus under root of 4 square minus 4 times 1 times minus 8, and then completely divided by 2 times 1. So x is equals to minus 4 plus minus under root of what? Under root of 16 plus 32, which means under root of 48, completely divided by 2. So as you know the fact that in place of under root of 48, what we can write is under root of 16 times under root of 3. So under root of 16 is basically the same thing as saying 4. So under root of 48 is 4 root 3. So therefore we can say that x is equals to minus 4 plus minus 4 root 3 completely divided by 2. Simple. So if you take 2 as common in the numerator, if you factor out 2 in the numerator, so taking 2 as common, multiplied by minus 2 plus minus 2 root 3, and this is completely over 2. So 2 and 2 is cancelled out. Okay, so therefore the x coordinates or the points of intersection are x is equals to minus 2 plus minus 2 root 3. But the requirement is not complete over here, because the purpose of solving the simultaneous equations is to find the points of intersections between the two graphs. Here we have 2 points of intersection. So here what we are going to do, we are going to substitute these roots of the equations of part A I mean, the equation, the quadratic equation, which we have shown in part A, we have obtained the roots over here in surd form. Now we are going to substitute it back into the equation of the line or the equation of the curve. So more simpler way is to just substitute this into the equation of the line so that we can get the corresponding y coordinates as well. Okay, so the requirement would only be complete when you are able to find the complete points of intersection in the form of x comma y. So what I'm going to do, I'm going to substitute these two roots, these two x values into the equation of the straight line. So equation of the straight line is y is equals to x minus 4. So first we have a root which is x is equals to minus 2 plus 2 root 3. So y will be equals to minus 2 plus 2 root 3 minus 4. Okay, so y will be equals to minus 6 plus 2 root 3. Okay, so one solution for your simultaneous equations is that x is equals to minus 2 plus 2 root 3. So y is equals to minus 6 plus 2 root 3. So here we can say that when x is equals to minus 2 plus 2 root 3, so the corresponding y coordinate is minus 6 plus 2 root 3. So now we have another x coordinate which is minus 2 minus 2 root 3. Okay, so the corresponding coordinate of y would be minus 2 root 3 minus 4, meaning y is equals to minus 6 minus 2 root 3. So when x is equals to minus 2 root 3, so the corresponding y coordinate is minus 6 minus 2 root 3. So in this way, we have solved the simultaneous linear and non-linear equations. So here is a requirement of this question, part B. All right, so now let's have a look at another question. It says that the equation x square plus kx plus k plus 3 is equal to 0, where k is a constant, has different real roots. Show that k square minus 4k minus 12 is greater than 0. Okay, so we have an equation x square plus kx plus k plus 3 is equal to 0. So what we are going to do, we are going to make a comparison with the form of ax square plus bx plus c is equal to 0. So therefore a is equals to 1, b is equals to k. As we can see that the coefficient of x is k, and c would be equals to k plus 3. So here we have identified at what's a, what's b, and what's c. Okay, so the condition given to us in the question is that this equation has two distinct roots, meaning when the roots are different, this means that you have two distinct roots. So in this case, b square minus 4ac is greater than 0. All right. So therefore, we can say that k square minus 4 times 1 times k plus 3 is greater than 0, meaning k square minus 4k minus 12 is greater than 0. Here we have shown an inequality in terms of k, which is k square minus 4k minus 12 is greater than 0. Okay, so here was a requirement of part A. So now for part B, it says that find the set of possible values of k, meaning you need to solve this quadratic inequality, uh, which you have shown in part A. You need to solve this quadratic inequality. Okay, so k square minus 4k minus 12 is greater than 0. So therefore, if you want to factorize it, so 6 times 2, and after subtraction, we need to get minus 4 in between. So k square plus 2k minus 6k minus 12 is greater than 0. So taking k as common multiplied by k plus 2, taking minus 6 as common multiplied by k plus 2, and this whole thing is greater than 0. So therefore, we can say that k plus 2 multiplied by k minus 6 is greater than 0. Okay, so basically you have a specific way to solve the quadratic inequalities. Okay, whenever you solve the quadratic inequalities, what you need to do is you need to take the help of the sketch of the quadratic graph. So this inequality is basically in terms of k. So what I'm going to do, I'm going to first of all equate both of the factors with 0. So first of all, k plus 2 is equals to 0. So therefore, k is equals to minus 2. And then k minus 6 is equals to 0, which means k is equals to 6. And since we are solving a quadratic inequality, here we are going to say that these are the critical values of k. We are going to say that these are the critical values of k. All right, this makes sense. So k is equals to minus 2 and k is equals to minus 6 will be, k is equals to minus 2 and k is equals to 6. They will be located over here. Okay, and since the inequality is in terms of k, so I'm going to just mention this is k axis, meaning the horizontal axis is k axis over here. Okay, and as we can see that the coefficient of k square is positive, meaning if we sketch a quadratic graph, so it would be a least turning point quadratic graph, the U-shaped quadratic graph. Okay, so therefore we have sketched it like this. And since the inequality is greater than 0, so this means that above the horizontal axis, the region which is above the horizontal axis, above the k-axis would be shaded. So the region which is bounded by the quadratic graph and the horizontal axis, this will be shaded. So either you can shade it in this way, or you can highlight the part of the graph in this way, that the part of the graph which is above the k-axis, above the horizontal axis, I'm shading it with orange pen. Okay, so according to our shading, our highlighting, everything, we can say that k is either less than minus 2, comma k is greater than 6. This is supposed to be our final answer. K is either below minus 2 or k is greater than 6. Okay, in the way which you solve the quadratic inequality, because usually the quadratic inequality is given to you in terms of x. However, in this case, the quadratic inequality is given to you in terms of k, in the form of k. So your answer would be in form of k. Okay, so k is either less than minus 2, comma k is greater than 6. Okay, so this was this question. All right, so now let's have a look at another question. Question number 11. It says that the equation x square plus kx plus 8 is equals to k has no real solutions for x. The requirement of part A is to show that k satisfies k square plus 4k minus 32 is less than 0. Okay, so the condition given to you is that it has no real solutions. So first of all, you are going to arrange it in this form: x square plus kx plus 8 minus k is equals to 0. So we are going to make a comparison with the form of ax square plus bx plus c is equals to 0. So this means that a is equals to 1, b is equals to k, and c is equals to 8 minus k. Okay. And the condition which is given to you in the question is that it has no real solutions, meaning it has no real roots. So this means that b square minus 4ac is less than 0. Okay. So here we are going to say that k square minus 4 times 1 times 8 minus k, and this whole thing is less than 0. So k square minus 4 times 1 times 8, so k square minus 32, k square minus 32, and then uh, plus 4k, meaning minus 4 into 1 into minus k. All right, and this whole thing is less than 0. So therefore, we have shown the quadratic inequality in terms of k as per the requirement of part A. K square plus 4k minus 32 is less than 0. All right, and then in part B, it says that hence find the set of possible values of k. So in the same way, you are going to solve the quadratic inequality over here. So 8 times 4 is 32. After subtraction, you need to get 4 in between. So k square plus 8k minus 4k minus 32 is less than 0. All right. So taking k as common multiplied by k plus 8, taking minus 4 as common multiplied by k plus 8, and this whole thing is less than 0. All right, so this means that k plus 8 multiplied by k minus 4 is less than 0. So what we are going to do, we are going to equate both of the factors with 0 in order to find the critical values of k. So first of all, k plus 8 is equals to 0, so k is equals to minus 8. And in the same way, k minus 4 is equal to 0, so k is equals to 4. Okay, so these are the critical values of k. So what I'm going to do, I'm going to make a sketch of a quadratic graph. And first of all, I'm going to locate these critical values over here. K is equals to minus 8 and k is equals to 4. And as we can see that the coefficient of k square is positive, meaning the quadratic graph will be a U-shaped quadratic graph, the least turning point quadratic graph. All right. And then according to the inequality, below the horizontal axis region would be shaded. So if you want to shade the part, so shade the part which is bounded by the quadratic graph and the horizontal axis, meaning the k axis over here, because the inequality is in terms of k. That's why horizontal axis is marked as k axis. So the region which is below the horizontal axis and it is bounded by the quadratic graph. So here we are going to shade this particular region between minus 8 and 4. However, if you want to mark the region, mark the part of the graph, mark the part of the graph which is below the horizontal axis, below the k-axis. So according to our shading and highlighting and marking each and everything, what we can say that k is between minus 8 and 4, meaning k is greater than minus 8 and less than 4. This is supposed to be our final answer. Okay, in the same way which you solve the quadratic inequalities, you have to attempt this part B. So in this video, I've discussed 3 questions from past papers. If you want to see more content on A-level mathematics, Cambridge and Edexcel, so follow my YouTube channel. Thanks for watching.